Alright class, this is Math 30-1 and then we're starting trigonometry. So we want to lay a good foundation, right, and have an understanding of what we're going to learn. In younger grade, you work with right angle triangle, so you only work with angles from 0 to 90 degree. And then when you learn about sine function, sine law, cosine law, you are able to work with angle that is going from 0 to 180 degree. But that's not enough. We want to cover all angles. So from all real numbers, like negative angles, positive angle, any angles. So that's why in grade 11, we already see it. We map angles, triangle on a coordinate system. So starting now, all the angles will be in a coordinate system. We set that is called angle in standard position. So these are not standard position. They're just triangle. You map a triangle on a coordinate system so that you can work with angle with any size. That is angle in standard position. You start in the x-axis, right, and then you rotate clockwise and all that. And then once you're on a coordinate system, you can rotate around 360 degree. But it's not just 360. Like you can see, there's a progression: 90 degree, 180 degree, 360 degree. Once you have 360 degree, you can keep going from 360 degree to the next cycle, 720 degree, right? You just keep going one more round. And then you can also go backwards, right? You can also go from 0 to negative 360 degree, or from the negative 360 to negative 70 to negative 720 degree. So you can keep going. So this way you cover all the possible angles. But then all you need to worry is just one cycle, because the rest, right, like the corresponding angle, like let's say angle 10 here, right? The corresponding angle will be like 370 here. They are also like 10 degree from the 360. They are coterminal angles. All the trig ratio, everything will be the same. So you don't need to worry about those. They are just repeating. So here, it results in periodic function, things that keep repeating. You just need to know what's happening in one, and then the rest just keep going. So we write a notation, whatever angle you plus 360 degree n. So this way it cover all the other one in other cycle. You just need to know the first one. And in this notation, that's called the principal angle. Now, we're going to work with radian. So another new thing in grade 12 is we're going to work with radian. 1 radian is about 57 degree. But we don't want to like keep converting this. We want to work on this unit by itself. So radian is arc length over radius. All right, so we already have seen this. So make sure you just know how to do this, and we know how to solve everything in terms of radian. So by going over these lessons again, just want to help you be familiar with radian. So when you have a circle, all right, one complete rotation is in degree is 360. And well, how about radian? I want to work with radian. Do they have one for radian? When you work with radian, is 2 pi in radian. Well, if you don't like the word pi, like this is an exact answer. You can also say it's roughly about, like pi is 3.14 times 2 is about 6.28. Okay, so for radian, not only is a new unit, it's also could be usually written in terms of pi. It could also be just written as a decimal. So maybe that's the complexity that it has. So in a circle, 1 is about this much, right? 1 pi, 1 radian, sorry, 1 pi, 1 radian, 2 radian, 3 radian, and 3.14 radian. So we call that pi. So pi is here. We can also say like half a pi, right? Half a pi. Or like 1/4 of a pi. Or 1/4 of a pi here, right? 1/4 of a pi here. So you need to work with like fractions, pi, even numbers. If I give you 2 as the radian, 2 is like roughly there, like 4, radian 4 is about there, radian 5, right? Radian 6, and then radian 2 pi. So it's a unit that you want to be familiar with. So since 360 equal to 2 pi, 180, half a circle is 1 pi. So these two equal, so if you put two equal things on top of each other, since they both equal to each other, this whole thing equal to 1. So this is a conversion factor. Since you multiply anything with 1, it's just itself. But if you multiply, right, you have an angle in degree, you multiply with 1 is still the same value. But by multiplying that, you're converting the factor. The degree cancel out. 60 and 180 will become a 3. So the answer is pi over 3. Pi over 3 in radian is same as 60 in degree. So you need to convert between them. Okay? So like there's some answers here. Convert to radian, it could have two questions. One is in terms of pi, one is just to the nearest tenth. All right, in terms of pi, then you leave the answer with a pi there. Now you do that. If you convert this fraction, this is 3, this is 2. So the answer is just 3 pi over 2, right? If the question say right as the nearest tenth, then you put it in the calculator. 3 times 3.14, so 9 point something divided by 2, so it's about 4.6 or 7, right? So that will be your nearest tenth. So neither way. Usually if it can be in a pi, then you write it as a pi. Okay, and like you can convert it back to degree by multiplying with pi in the bottom, 180 degree on top. So for a question like this, for converting from radian to degree, you can have a radian that has a pi, so the pi and pi cancel out. Okay, so the pi and pi cancel out. So 180 divided by 4, so that's 45 degree. For converting radian to degree, you can have a radian that without a pi, right? Like here, without a pi. So, but you still multiply with the same conversion factor. Then in your calculator, type 1.4 negative times 180 divided by 3.14. Then you get a whatever answer, so that will be your answer in radian. All right. So, like for this one, usually they won't ask you to write the answer in radian. Let's say I want to turn 2 radian into degree. Okay. Then you punch this whole thing in, divide by pi, and then you get a rough number like 114, something like that. Well, if you leave it in exact form, sure, you could, right? You multiply this together, well, the pi exact form, then you leave it. The answer will be 360 divided by pi. But usually that will not be the representation you want. Like you're in degree, so you don't need pi, right? Like divide by pi will be like 114, like 15 degrees. So they are just different form they may ask you to do, then you just follow the instruction. Okay, so all this concept, coterminal angle, principal angle, reference angle, but now doing it in terms of radian. So we have complete this table, right? Maybe I can do it again. They want to find out the rotational angle, rotation angle. Given reference angle, it is the same. Reference angle is an angle always between 0 and 90 degree, between 0 and pi over 2. So in this quadrant will be pi minus reference, right? Then you have like a half a circle minus the reference angle. Then you end up with the angle on the second quadrant. And next one will be pi plus reference angle. And finally will be 2 pi minus reference angle. We can have another table about reference angle, how to find the reference angle given the angle. Again, like reference angle, it could only be 0 to 90 degrees, 0 to pi over 2. Rotational angle is any angle, okay, in a full circle, 0 to 360 degree, 0 to 2 pi radian. So it could be bigger than 90 degrees. So the rotational angle given, if it's the rotational angle in the first quadrant, it will be just the reference angle. And then pi minus the rotational angle in the second quadrant is the reference angle. Next, the rotational angle in the third quadrant is bigger than pi. So if you minus pi, then it will be the reference angle. Finally, 2 pi minus um, 2 pi minus the rotational angle, okay, will be the reference angle. So the only difference between the two is that it's in the third quadrant. But if you have a picture in mind, you know what angle you're working with, you can figure that out. So you don't, right? Like, do you need to memorize it, right? Or like, if you understand this, you basically memorize it already. Okay, so now here we already did this, but let me give you some other question. Let's say, okay, here, let's say I want to graph 5 pi over 7. Okay, I want to draw 5 pi over 7. First, this is an odd number. You have a pi. You want to cut it in 7 pieces, right? You want to cut it in 7 pieces because you want things in part of 7. But 7 is an odd number. So first insert, ignore the line in the middle here. First insert a piece there. So you've done one piece. So 7 minus one piece is 6. You have two sides. So each side you need 3 pieces. So in here, I cut in 3 pieces. Here, right? 1, 2, 3. In the pieces in the middle. And then 3 pieces here. Now I have 7 pieces. Do you see that? All right. So for odd number, you ignore the line in the middle. But for even number, you put a line in the middle. When you cut in even, you first cut in half. Now I want 5 pi over 7 pieces. So you just count starting here. 1, right? Starting here. 1, 2, 3, 4, 5. So this will be my answer. Okay, if I now ask you what's the reference angle, how far is this line away from the axis? You will see, well, there's 2 pieces left. So the reference angle here will be 2 pi over 7. Okay, so for angle that has the denominator 3, 4, 6, and 2, the reference angle will just be pi over 3, 4, 6, and 2, like 2, 3, 4, 6. But then for any side, any other number, then you actually need to draw it, see it to figure it out. Like it could be any parts of the pi over 7, right? Not necessarily just pi over 7, but it won't be the case for 2, 3, 4, 6. It would just always be pi over 2, 3, 4, 6. So that's the shortcut. Well, if you don't believe it, you can draw one and see. Okay, let's say this one. Okay, so 6 pieces is an even number, so I just need to cut 3 here, cut 3 here, so I have 6 pieces for the pi. So let's also do this on this side, do this on this side. 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, right? 18, 20, 19, 20, 21, 22, 23. So this would be 23 pi over 6. How far is it from the x-axis? 1 piece away. Okay? It's always 1 piece away, no matter how you draw it, for fraction 2, 3, 4, 6. The reason is it is in the lowest reduced form. Like if you draw it out, you will see that's the case. And then we have some question making use of this formula. So I think we like gone through all this example already, but let's just try one more to end. Okay, so this is a question with a center C. The angle is always with the radius here, right? Radius with the arc length, and then the angle that makes here. So it's always the center angle. It's always there. But for this question, they didn't give you the center angle. They give you the angle ABC. They give you this angle, right, and this angle. So then you need to apply the concept of all 3 angles in a triangle add up to 180. So 3 angle add up to 180. So in here, they add up the angle in radian add up to pi. That's 180. So you find out your pi is 4 pi over 6, which is 2 pi over 3. And then you use that in your formula, plug it in A over R to solve for the questions. Okay, so that's it for lesson 2. Good luck.